Okay, so today I want to talk about a new model from Qwen, and this is Qwen 2.5 Omni. So already we've seen Qwen release reasoning models, we've seen them release the VLMs, we've seen them release a whole bunch of different sizes for the LLMs. As far as I know, this is their first Omni model that they've put out. And this is pretty damn cool, right? So for a start, I'm not talking about a model here that is proprietary and that we don't have access to. This is an open source model that you can download, you can try out, you can use for your projects. And it's Omni in that it's fully multimodal in regards to inputs that we can put text into it, audio into it, video into it, images into it, and we can get out either text or audio in the form of a voice coming out of this. So this is pretty amazing. Let's jump and just have a quick look at it before I go through what they're doing here. Okay, so if we come into the Qwen chat in here and we basically pick this use voice and video chat, I'm going to start off with just a voice chat. Let's see how it goes. Hi, how are you doing?
I'm doing pretty well, thanks for asking. How about you? What's been going on in your world lately?
I'm good. I'm checking out the new Qwen Omni model. Do you know much about that?
Oh, that sounds really cool. It must be quite an upgrade from the previous models. Have you had a chance to try it out yet? And what do you think about its features so far?
So actually, I'm trying it by speaking to you right now.
That's great. I'm glad it's working well for you. If you have any specific questions or need help with something related to it, feel free to ask me.
So can you make sounds? Like, can you make the sound of thunder?
Well, I can't physically make sounds like thunder myself. But if you're looking for ways to create thunder-like sounds, there are some apps or sound effects libraries online where you might find them.
All right, so as we can see there, it looks like it can just do voices.
Oh, I am Qwen. Is there anything you'd like to share with me? If you need help with anything else,
Hello, I'm Qwen. Is there anything you'd like to share with me?
Okay, so there's different voices that you can pick from.
Hello, is there anything you'd like to share with me?
Hello, I am Qwen. Is there anything you'd like to share with me?
Okay, and something makes me think that the virtual girlfriend voice is probably going to get a fair bit of use in here.
Hello, I'm Qwen. Is there anything you'd like to share with me?
So you can see for voice chat, it works really well. And we can basically have a question. Can you tell me a little bit about the GSM 8K dataset?
GSM 8K dataset is quite interesting. It's a large-scale dataset for natural language understanding tasks. It contains around 10,000 high-quality conversations in English.
Okay, so you can see here that clearly this is a much better LLM model than what Moshi kind of had, right? Meaning that Moshi, if you look at my video of that, it was quite amusing where you would ask it certain things and it would interpret it totally differently and go around different things. Let's try out the video section. Hello, Qwen. Can you see how many fingers I've got held up?
Sure, I can see that you have 5 fingers held up. If T here is anything else you want to know or talk about, feel free to let me know.
Yeah, tell me, what can you see in the background?
Well, in the background, there are quite a few things. There are bookshelves filled with books all over the place. You can also see some posters on the wall, like one that says PROSED and BEBOLD. And there are various other items scattered around, such as a colorful pillow, some electronic devices, and what looks like a basket.
What is the logo for that's here?
Oh, that logo is for Google Chrome. It has those 3 colors, red, yellow, and green, arranged in a circle. Pretty recognizable, right? If you have any more
That's very good. All right. Thank you. Thank you, Qwen. Okay, so as you can see, it's pretty impressive on what it can do both with audio input output and video input output. So they've called this the Qwen Omni model. It's only 7 billion parameters, which is kind of amazing for what it can do. I really think that we're seeing a lot of these companies really push the boundaries of what actually can be done with a model that's under 10 billion parameters. Anyway, here they basically talk about Omni as being their new flagship end-to-end multimodal model. And it's basically set up to be able to take text in, images in, audio, and video. And at the same time, it can deliver back real-time streaming responses, both through sort of text generation and natural synthesis. So just to put this in perspective, so far the only companies that we've really seen being able to do this well have been OpenAI and Google. And obviously, neither of those models are open weights, and neither of them are things that you can basically run locally. You've got to use their API, you've got to factor in all the elements with the API, etc. So one of the cool things that we've got here is that not only have they released the model and everything that goes with that, as we can see already, all of that is up on Hugging Face. You can download, you can try this, and we'll have a play with this in Colab later on in the video. But on top of that, they've also released this paper, which basically goes into the full details of how they've done it and what they're actually using to do it. So I think the key takeaway here is this thinker-talker architecture that they've got here. So in some ways, this is similar to things we've seen before. So basically, you have the Omni Thinker, which is kind of like a standard LLM in many ways. It's a transformer decoder model. And then going into that, we've got both a vision encoder and an audio encoder. So I've seen this with things like the 5.4 model and stuff like that. For the vision encoder, there are obviously lots of different models that are doing this kind of thing. And so they basically convert them to tokens that go into the LLM. Now, the interesting stuff happens is that the LLM, or what they're calling the thinker model here, doesn't just output nice words, which then get sent to a TTS system or something. They output representations that go into the second transformer here, which is the Omni Talker. So this is a streaming diffusion transformer, which basically converts the representations of what's coming out of the LLM into audio. So it can actually be converted into streaming audio and actual sounds and stuff like that coming out of this. Now, to do this, they've got their own tokenization system for that that's coming out. And we can see that's generating out both text tokens, but also these codec tokens, which go into this streaming decoder here. So what this kind of means is that we've got this thinker component, which is kind of acting like the brain of the system. We've got these encoder things for vision and for audio that send things into that brain. And then that thinking component can deal with all the different modalities, whether that's text, whether that's audio, whether that's images that are still images or video images, etc. And then it generates out these high-level representations as it goes. Obviously, because it's LLM, it can produce the text out if we just wanted text out of the model. The talker component, it's kind of like the mouth system, right? This is the audio sort of decoder system that they've got here. It takes these high-dimensional representations from the thinker model and is able then to generate speech tokens, which go to the audio decoder and become streaming audio out of this thing. So it looks like this is basically trained in an end-to-end fashion. And one of the things that they talk about in the paper that they've come up for this is a whole new way of sort of this time-aligned multimodal rope or rotary positioning embedding. So basically, how do they get the embeddings so that for things like audio and video, it kind of knows what happened when there. So these new positional embeddings allow it to basically organize like video frames, interleave the audio and stuff like that with a kind of timestamp so that it can basically make use of the temporal information that's coming in, whether that's from sort of video or audio as you go through this. So just to sort of sum this architecture up, you've basically got it where the user input is coming in. This could be audio, video, or even things like text. The thinker then processes that and generates these representations. And if you just wanted text out, then the thinker can just do that. For speech generation, the thinker then passes it on to the talker module, and the talker then takes those representations and generates speech, which go into this diffusion transformer and then finally out through an audio decoder. So I've got to say, it's really kind of amazing how they've got this all together in such a small package. Honestly, I would have been less surprised if this had come out maybe as a 32B model or something like that. But I guess to be able to run it real time, they've got to keep the model pretty small. But that said, you can see that like this is operating in a much better way than we saw things like Moshi and some similar things that we've seen out there like this. And I think really we've got to start thinking of this as being perhaps the new kind of architecture that eventually we may see the majority of models start using, where we can basically have it be fully multimodal in. The only thing I guess we're missing here is the whole Ghibli effect. And it does seem like that may have stolen some of their thunder. The fact that everyone's using these OpenAI models to turn people into cartoons. Personally, I think this is actually a lot more interesting, and especially because it's open, right? I really can't stress enough how cool it is that an AI lab is actually releasing this as open weights for us to be able to play with. So they've done some benchmarks against other models, including Gemini 1.5, which is kind of interesting in here, just to compare how the model is doing on various modalities and stuff like that. And one of the key things that we do see with these multimodal models is that surprisingly, the more tasks that you get it to do, actually, the more the model gets to be better at generalizing to things overall. And while this may not be the state-of-the-art model for each individual thing at the moment, I do think this direction is much more interesting than just going for incremental improvements on SOTA benchmarks and stuff like that. All right, let's jump into the code, have a play with it, see what we can do with it in the actual code. Okay, so to get this working, you're going to need the latest version of Transformers or a new commit for Transformers. So basically just uninstall the old Transformers and install the new one. You also need some Qwen Omni utils in here, and ideally you need flash attention, which basically means we need a pretty big GPU. So I'm using an A100 GPU in here to get this going. Now, loading the model is pretty simple. You just want to make sure that you're using flash attention. Otherwise, it's just very slow to use. Now, one of the things that I noticed playing around with the model is the actual model size. So calling the model a 7B model is not quite accurate. Altogether, it's a bit under 11B or 10.7B, as you can see in here. And if we pull the model apart, we can actually see what's going on. So we've got the model thinker part, and I'll break that down in a sec as well. And then we've got the model talker part. We see that the model talker part is pretty small. This is 1.3 billion as opposed to sort of 9 billion for the thinker. But actually, if we break the thinker apart into sort of like the visual encoder, and the base model itself is about a 7B. I guess the 7B sort of name comes from the base LLM model in here. That said, I still don't think this is a really huge deal in that it's still an amazing model for 10, 11B compared to the proprietary versions of these models, which are much bigger in there. All right, it uses the standard ML chat format. You can pass in images or video or audio, etc. as well. You've basically got the processor, which will process both the video and audio. And then when you actually do the inference, you will get back text IDs and the audio in here. Now you can decode that text back. And so you can see here that basically I've sent through the who are you. And if we look at it, we get back, I am Qwen, a large-scale language model developed by Alibaba Cloud. How can I assist you? Now, the audio for that, we also got the audio back. We want to basically save that out to a WAV file or something like that. And I've basically saved that out, and we can just play that.
I'm Qwen, a large-scale language model developed by Alibaba Cloud. How can I assist you?
Okay, and so you can see it just matched what we got out there. So I've put together a little function where you can select the speaker and it will basically do it for you. It's quite nice in how you do this. And remember, this is not like a TTS system. This is using this sort of Omni model where the whole thing is being done in one shot. So when I ask it, what do you think the meaning of life is? And then, is it 42? I get this back.
Well, that's a really interesting question. I don't think 42 is the meaning of life. It's just a number in Douglas Adams's The Hitchhiker's Guide to the Galaxy. For me, the meaning of life could be different things for different people. Some might say it's about finding happiness. Others.
All right, I'll just leave it there to save time. Go and have a play with the notebook. The link is in the description, same as always, if you want to try it out, etc. The thing that I noticed there, like it gets the word galaxy wrong. So there's some small things like that, but it is pretty amazing. Now, if you pass in a different speaker, so here I'm basically passing in the male speaker. I'm asking it to compare Paris and Beijing. Let's listen to it.
Well, Paris is a really romantic and artistic city. It has the Eiffel Tower, which is super famous. There are lots of beautiful parks and cafes. The food is amazing too, like croissants and cheese. Beijing, on the other hand, has a rich history. The Forbidden City is a must-see. It has a different kind of beauty, more traditional and cultural. The food there is also great, with things like Peking duck. Both
Okay, I'll leave it there again for time's sake. But it's really impressive how it can basically give the answer back in a different voice, etc. as you go through. I'll leave this one. It does a really nice take on the what is the difference between llamas, vicunas, alpacas. And to think it was just sort of 2 years ago that I created this prompt when we were testing out the alpaca model, the vicuna model, the original llama model. It's amazing to think just how far we've actually come. There's also some code in there if you wanted to do things like batch inference, so you can actually do multiple batches at once with this. And like I showed you above, all of this, you can actually come in here and see how they're doing it. We can see here, like if we wanted to see the audio encoder, we can come in and see like what are they actually using for these kind of things. This is really awesome that basically all of this is open so that you can learn from it, you could pull it apart, etc. And don't forget, when we come back in here and look at this, is an Apache 2 license. So if you wanted to basically reuse the audio encoder or reuse parts of this, I really think it's really going to be fantastic to see what people do with this. It's going to be very interesting to see how you could sort of fine tune the language model part of this to have a personality and then fine tune a voice to match that personality as you go through. So really this for me is one of the most interesting models that we've seen in quite a while. I hope we see this in things like a llama, perhaps in a MLX version, etc. Because really this could be like the perfect front end to a local agent system that you could basically talk to it. You can give it images, you can give it videos, it can go off and do things. My guess is currently this is not trained for doing anything like function calling, but I can imagine that's probably not that far off with this kind of thing. And then you can imagine that running totally locally on your computer, perhaps you need some reasonably decent specs to do that at the moment, but still this is pretty amazing. And like I keep saying, it's all open, meaning you can do whatever you want with this. I'd love to hear your thoughts in the comments about what you think of this, if you've had a play with the version online or one of the Hugging Face Spaces demos, etc. It's really worth checking out. And this is where I think we're going to see these local models go. As they become better at doing these kind of things, you could imagine that you can have one of these models that could use bigger, smarter models just as a tool so that you've got this conversational sort of system going, and then it could use one of the reasoning models for handling more complex kind of things. Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video.